So I entitled this presentation Career Pathways in Data Science and Deep Learning. And I will talk a little bit about data science and deep learning, but mostly about career and the ups and downs. And maybe you'll find this quite interesting because oftentimes you see careers and you see that they are straight ahead and everything went really well, but there's also quite of downsides that many people don't talk about. So I will talk about essentially my lab, my research, and then my personal career. I hope you can read this and that the font is not too small. So, and I also want to talk about all the pitfalls that actually typically people just leave away. And today I don't want to leave them away. So you may wonder, I'm from Erlangen-Nuremberg University, and you may wonder, Erlangen, some people have never heard about the place. Depends on what your background is. So I brought this map of Europe, and I'm already focusing here on Central Europe. And you can see that there's a tiny dot in the center of Germany here, and this tiny dot is Erlangen. So you may find the United Kingdom on the top left, or other European countries. Germany is in the very center of Europe, and Erlangen is essentially in the very center of Europe. So if you Google for Erlangen, if you hadn't heard about it, then the first thing that you will find is Erlangen Beer Festival. So this is the auto-completion. So there's a beer festival here because we're located in Bavaria, to be exact, Franconia. And of course, people here in the region are very proud of the many different kinds of beer that they produce. And we have probably one of the highest brewery densities in all over Europe. So, but other than beer, we also have a university here, the university I work for. And if you look into the Wikipedia entry, you can find that there's essentially two things that are of relevance in Erlangen. This is the university, and the other thing is in Erlangen, the headquarters of Siemens Healthcare are located. So a lot of the industry here is driven by Siemens, and in particular in the medcare or healthcare sector. And the other thing that's important is the university. It's a small city, maybe 100,000 inhabitants, but it's very international because driven by global players, we also have quite an international atmosphere here. So most of the daily life can also be conducted in English and so on. So another thing that might be interesting about Erlangen is that MP3 was invented here by the Fraunhofer Institute. So only like 5 kilometers away from where I'm located right now, they invented the MP3 standard. Okay, so one thing that may also be interesting is that in Bavaria, they decided to found hubs for specific disciplines of AI, and Erlangen is becoming the hub of AI in healthcare or AI in medicine. And there's 20 new professors that are being hired right now only to support further research in artificial intelligence in medicine. So the lab that I'm heading is actually a computer science lab. It's called the Pattern Recognition Lab. It was founded in 1974, and we've been doing pattern recognition since then. And you can see that pattern recognition is a term that is typically used in electrical engineering when you want to refer to machine learning technologies. So if you come more from the electrical engineering and the sites that are close to the sensors, you probably learn about pattern recognition. If you're in computer science, then you do machine learning, or also related to artificial intelligence, of course. And if you're from the databases, then you typically talk about data mining, but all three of them essentially are referring to machine learning. And today everybody is talking about artificial intelligence. Well, yeah, we are also in this kind of terms, and we are working in this since 1974. Right now we have 2 professors, 1 lecturer, and there's 2 more postdocs. We have a total of 50 Ph.D. students working in the lab. So it's actually the biggest lab in computer science located here in Erlangen. And we have some 10 work groups, and you can see they work in image reconstruction, image fusion, image analysis, X-ray phase contrast, computer vision, speech processing and understanding, and of course also big data learning algorithms for medical big data. So I'm not listing all of the groups, so quite a few things going on here. And I also brought a couple of examples. So this is now the research part. We work to about 70% in biomedical image and data processing. You can, of course, guess that with Siemens Healthcare is located here, is a good opportunity to work in this area. We have some work in computer vision, some work in speech recognition, and lately we've been doing digital humanities. So this is when you use AI techniques essentially for understanding of history, and this is also a very interesting field and also kind of hobby of mine. So this is something that I also like to push a bit, and lately we were quite successful in acquiring third-party funding for those purposes. So you can see some examples here. This is the kind of devices that we're working with, and you see most of them are, of course, medical devices from X-ray, MR, CT, nuclear medicine, all kinds of imaging devices, interventional devices. So they're operated in the operation theater, in the operating room. So there also has to be real-time processing such that you get the images and process them right away, highlight organs, organs of risk, and so on. We also do some other modalities. I'm not listing everything that we're doing here, but so for example, the bottom right one is ophthalmic imaging, where you image the eye in 3D and the retina in 3D. Here are some examples. Of course, a lot of what we're doing has to do with image analysis. You do tumor segmentation, you segment the heart and its chambers. You go to the background of the eye and segment vessels. You can also segment vessels of the heart. You can also segment the diaphragm and all kinds of anatomy. So we have essentially, most of our work is concerned about one complex object, that is the human body, and many different ways of looking at the human body with different physical measurement principles. So I have some examples that I want to highlight. One here, so this was presented on MICAI in 2017, and actually won the young researcher, young investigator award. So this is one of the 5 works that have been selected in that year among more than 1,000 submissions. And what you can see here is the idea of using reinforcement learning in order to mimic how a radiologist looks at an image. Typically, when you try to find anatomy, you would parse the entire volume and then just highlight the position that fits best. Here we train an agent, and the agent looks at small patches, small cubes of the volume, and then it decides to move towards the landmark or anatomy of interest. And we do that in a multi-scale approach. So we're not just looking in a very coarse resolution, but then we also zoom in and magnify and run the detection again. And the agent essentially decides to move up, down, left, right, back and forth. And then we gradually approach where the landmark position is. So here, this process seems to be very slow, but actually we only look at the fraction of the volume, and we can process entire CT volumes very quickly. We can do about 200 landmarks in 2 seconds on a full body CT in this way. So it's a very quick way of finding where the anatomy of interest is. And the other cool thing is you kind of can interpret what the system has been doing, because you can essentially follow the path and you see that the anatomy somehow is parsed and makes sense. And if you have the case that a landmark isn't present in the volume, our agent really does what a radiologist would do. It would try to leave the volume if it's not inside of the volume. So this is a very cool approach. It's using reinforcement learning in order to spot specific landmarks. And we also extended this for detection of landmarks in X-ray projection images. So here you see a hip bone and specific points on that hip bone that have been annotated. And we trained a very nice, system that would then detect those landmarks in real time in the X-ray projections. And you can see that this is a view-by-view processing, but it looks like we're tracking those landmarks. So the idea here is that in the future, we want to use these techniques to replace implanted markers by tracking of anatomy. So for example, in radiation therapy, you sometimes have to implant gold markers, and this way you could use the anatomy itself in order to find the landmarks and do registration, find the organs that you actually want to irradiate. So also a very nice method. And by the way, this year, this was 2018, we won the second time in a row this Young Investigator Award on MICAI. So that's also actually a quite nice result. Well, what else? Of course, we do deep learning in all kinds of applications. Most of the fields that we're working in, we're using deep learning right now. You can take population data, use a net and predict the patient surface, as you see on the top left. You can use it for writer identification, where you extract features from writings and try to predict who wrote the text, which is very interesting if you're thinking about the historical applications. So there sometimes you don't know who has been writing a specific text, and then you can match the writing to texts where you already know who the writer was, so you can identify who that person was. Or if you also have a document of unknown origin, then you can at least analyze how many writers have been actually working on this manuscript, and you don't need expert writing, but you can also do this as an automatic system. We also just very recently started a project where we're using deep learning techniques to look at calls of orca whales that you see on the bottom left. So here we're trying to cluster, first of all, to detect calls of orcas. So there are archives around that have like 40,000 hours of underwater recordings in regions where orcas typically live. But of course, more than 90% of the recordings do not contain any recordings of whales because they simply weren't present. So the first task is to remove those 90% of recordings that don't contain any calls by the orcas. And then you want to find only the relevant segments, then cluster them and help to actually figure out what's going on in those calls. And the fourth application that I'm showing here is irradiance forecasting. So this is taking a camera, looking at the sky and predict the output of a solar power plant within the next 10 minutes. And this is very much dependent on the local weather. And if you're into renewable energy, then you know that in countries like Germany, the net stability may be a problem. So you want to know 10 minutes in advance when your power plant stops producing energy such that you can fire up a backup generator. And we had hard time with traditional pattern recognition methods. With deep learning techniques already in 2014, we could show that we can get this 10-minute prediction pretty stable. So this is also very nice kind of application. So I'll stop talking about, I could go on for hours about those topics, of course, but I'll stop talking about the research and rather discuss a few points in my career, because I think that may be interesting for you, and also if you have some career decisions coming up, then maybe this can be helpful for you. So if you look at my CV, you would see those career milestones. I had a diploma thesis that I submitted in 2005 in computer science, was actually in speech recognition. And later I worked on a Ph.D. project, again in medical speech recognition. And this was funded by the DFG, the German Research Council. So this is one of the projects that are more hard to get. And if you do a PhD project within funding from the DFG, this is really nice because you have essentially 3 years of research support, and only after 3 years you actually submit the final report, and then this can be very close to what you're actually writing up with what's in your PhD thesis. So this is a very nice working towards research. You have quite a few degrees of freedom in there, so that's very nice. After my PhD, I went on to do a postdoc in Stanford in the Radiological Sciences Laboratory. So again, something that's related to medicine, this time image processing and processing of X-ray images. And after doing the postdoc in Stanford, I returned to Germany. I got offered a permanent lecturer position at FAU in 2011. Then shortly after that, I took a leave of absence to work in industry. So I was still on the permanent position at Erlangen University, but I was still got this offer to work for Siemens and to get some industry experience. I was working there for 1.5 years. And after 1.5 years, I returned to the university. Then in 2012, I returned. 2015, I became the head of the pattern recognition lab. Then in 2017, I took on a position, so still head of the pattern recognition lab, but I joined a large European research effort that is called the European Time Machine Project. So I'm not sure if you heard about that. So there's approximately 400 partners all across Europe that are joining this effort, and they're trying to build a large scale document and image processing, speech processing, text processing engine that would then allow it to get access to 2000 years of European history. So it's probably the largest history database that the Time Machine Project tries to construct. It's quite exciting to work in such a team, and I got elected into the executive board of this European Time Machine Project. 2018, I won an ESC Synergy grant, and this was about the fusion of deep learning and AI techniques and image reconstruction. So this was also, the ERC Synergy grants are really hard to get. So typically 90% of the submissions are rejected and only 10 to 3% are successful and selected. So this is actually a quite big achievement. And the project, the Synergy grant, 3 PIs, 12.3 million euro of funding. So a really big research project for a small group of PIs. Then 2020, so just this year, I got tenured. So I'm a full tenure professor at FAU right now. And this way, I also got contact with Asif, and now I have a new milestone, which is this fireplace talk here at MarTech Post, which is the last milestone in my current career. So this is how you would present your CV, of course, to other people, right? So you only show all the positive things and you keep out all the negative things. But what I want to show you in this presentation is there's actually a true story, and you don't talk about the pitfalls typically. So already when I started my diploma thesis, or the choice of doing speech recognition was actually a quite interesting one. So when I was studying computer science, I decided to take Japanese language as a minor subject. And when doing Japanese, I decided that at some point I want to learn the language much better, so I need to go to Japan and do something there. So I applied for an internship, and the internship position I applied for was actually in speech recognition. So I started doing speech recognition essentially in Japan because I wanted to go to learn the language, and later on then I actually went on to do my diploma thesis in this topic, and then also my PhD in medical speech processing. But the actual decision to do speech was when I went to Japan and did an internship there, which is probably not, people will tell you, well, why did you select speech? Well, there was a cool internship position in Japan, and I'd like to go there. Later, I told you I have this DFG project, and this is very relaxed and it's very nice to work in the DFG project. But actually, there was no funding for a PhD position whatsoever. When I decided that I want to do a PhD, I actually had only a startup money for 6 months of PhD. And within these 6 months, we were able to secure more grants, and then finally this DFG project. So I was quite heavily involved already in grant writing at a very early stage in my PhD. And I was really lucky that the project was granted, because if it weren't granted, then probably there would not have been any financing, and I might have quit doing a PhD, or I might have moved abroad, or might have done something completely else. So there was already at this stage quite a bit of luck involved that I could do a PhD, and I was able to secure the funding for that. So I already told you I went to Japan, and then I went on to do a postdoc after my PhD. So I decided that I want to stay in academia for some time. So I was searching for a postdoc position, and I came into my boss's office one morning, and he said, look, you told me 2 days ago that you want to stay in academia, so you have to do a postdoc. And I've seen in the newspaper there's grants that you can go to Japan. So why don't you apply for grants to go to Japan? And I said, like, look, I've already been in Japan, and yeah, I would like to see other parts of the world. Maybe the US would be nice. And then he said, look, this morning he got this email that a colleague is advertising a postdoc position in Stanford, but it's not speech, it's X-ray reconstruction. And I said, oh, it's X-ray reconstruction, so it's image processing. It's something that I haven't been doing at all to this point in time. I applied. I got very good references from my professor, and I got lucky and got the position. And then essentially on the way traveling to the US to work at Stanford, I was reading the first textbooks on image reconstruction. I had no idea whatsoever about image reconstruction, but I got this opportunity to go to Stanford. So you better want to be prepared when you start there, right? So essentially on the plane, I was reading this book about image reconstruction. So I started off flying from Germany as a speech expert with a Ph.D. degree in medical speech processing, and I arrived a couple of hours later as a medical image processing expert who was going to work on image reconstruction. This was a pretty bold move, and luckily it turned out that I was able to learn the stuff and also do my research at Stanford. But it was a kind of risky move, but still I really wanted to go to Stanford, and I really wanted to learn about image reconstruction. So it kind of also went off. When I was at Stanford, I already applied for other positions, and amongst them was a position at the Technical University in Munich, Germany. And I got very far in the selection process, really, really far. And then I decided that I want to go back to Germany, and essentially already started packing my things there and really made the move. And then in the very last moment, essentially right before I was appointed, the president of the university decided that he would cancel the third-party funding that would actually fund the specific professorship. So I had the interview. I even had an email saying that I'm listed as the first person on the list. So I would get an offer. And before I got the offer letter, the position was canceled. So I was essentially going back to Germany, and luckily I asked my former professor if he still has a job. He said, yes, I'm going to take you again. And there were 2 people in his lab really fighting really bad about one permanent position. And in the end, the fights between the 2 got so bad that both of them quit. And I got offered the permanent position in the lab, which was kind of really crazy, yeah? That you already try to go off to some very other place, you almost have the offer, and this offer is canceled. And then I just got lucky that I had this kind of invitation to go to a permanent position, which are also quite hard to get. So although the associate professorship in Munich didn't work out, I still found a different solution. So then you could say, okay, why are you then going to industry? And well, I was on a permanent position. I already got in contact with big industry like Siemens, because Siemens also had a relation with Stanford, and they actually went to visit and they saw my research at Stanford. And then they asked me, look, what you're presenting here, you have kind of a German accent. Where in Germany are you from? And I said, like, I'm from Erlangen. And Siemens is located in Erlangen. I said, look, we've never seen you in Erlangen. How come that you do medical image processing? We never heard of you. And you're now in Stanford. I said, look, I was doing speech. So I kind of got to know the guys at Siemens, very friendly and so on. And then I got in contact with them. They kind of needed somebody in their innovation team, so like pre-development. And my boss at FAU, he said, look, there's this open position at Siemens, why don't you apply there? And I said, look, I just decided for a permanent position here at FAU, why should I go to Siemens? And he said, like, yeah, but you are working now in medical imaging, and Siemens is one of the premier industry partners here. So if you go work there, you can understand them much better. And by the way, maybe you like it much better in industry. And he was right. So I went on, got a leave of absence at FAU, and I went to Siemens. And this way I had like 2 permanent contracts at the same time. So I had 1 permanent contract with Siemens and 1 permanent contract with FAU. And then I could essentially test, no risk, which I like better. And to be honest, I like both of them very much. So industry was very cool, pre-development. They do a lot of research. They don't talk about all the research that they're doing, but they do really cool research. And then I was kind of really struggling which side to take. And at some point, I got an email from my former professor, just in all caps, and it was just saying, please come back. And at that point, then essentially I decided, okay, I want to return to academia. Its pay isn't that good as at Siemens, but you have a lot of freedom. And I really knew that I got along with my former professor really well. So I decided, okay, I go back, and I know who's going to be my boss. So it's going to be the same time. I'll just be working there as a lecturer until retirement, and everything is fine. That's what I thought. I just returned, and when I returned, I realized that my boss already had been elected to vice president of the university. So I actually had to take over quite a few of his duties. And until 2015, he was elected president of the university. So suddenly, my boss, the guy I wanted to work with until my retirement, was promoted president, and his position was vacant. And they needed somebody to fill in that position. And for whatever reason, he said, look, you just finished your habilitation and you have all the permissions to head a lab. So now you do my job and I go be president. And we'll do that for the next 5 years. And in 5 years, we'll decide. Oh, I said, oh, cool, I can head the lab. So yeah, why not do it? Yeah, sounds like a good offer. So I went on to become the head of the lab, where I actually did my Ph.D. And what was also quite amazing is I wasn't doing my Ph.D. in the speech group, and the professor heading the speech group wasn't the head of the lab. And suddenly I was the head of the lab, and I was essentially the head of my former Ph.D. supervisor, which is also he's a really nice guy. We got along very well, so there was no really strange situation. But I got promoted to become the lead of my own PhD supervisor. Very interesting situation. Well, the problem with that position is it's a 5-year limited position. And in Germany, if the president is re-elected, his lab is going to be filled by a new professor, and that has to be an external person. So there's no way that you can actually be that I could actually take over the lab at some point. And of course, if he came back and wouldn't be re-elected, everything would have been fine. But there's also the risk that he gets re-elected, and then suddenly I have a new head of the lab, somebody who would then know that I've been heading the lab for 5 years, already know, okay, this guy can head the lab. And it's not unlikely that such a person would then simply say, oh, you've been doing this for 5 years, go on, do it for the rest of your life, and I take all the credit. So that's some situation that I didn't want to end up with. So I started then, once I realized that, applying at many positions. And what you don't find in my CV is that I applied for more than 40 other positions, more than that. So I've been writing essentially every week on every second weekend, one application for becoming a professor at a different university. And things didn't go very well at the time. Of course, heading the lab was very nice, and we were doing really nice research. You can see that in the previous slides, I showed you that we also won a couple of awards. Then in 2018, we were successful with this ERC grant, and these are really difficult to get. And the nice thing about the ERC grant is that DFG and ERC money is bound to the person that won the grant. So it's not to the lab or the university, but it's money where I can decide that where this money is being used. And I tell you, if I win a grant, which is a third of 12.3 million euro, and then you apply for positions and you can move it to your new university, then suddenly you have a lot of friends. So after I got this grant, suddenly my applications were successful. And suddenly my university kind of got afraid that I would take my 4 million euro and all the other third-party money that I was already acquiring over the years and just leave with that. And then, although it's actually impossible to get a professorship at the university you already work for, there are exceptions. And yeah, then they're actually in 2020, so just this year in April, I got appointed as full tenure professor and can stay in this position until my retirement. So there's no way I can be demoted to lecturer again, which could have been all the time in the previous years. So another interesting thing is the story where I got part of the European Time Machine project. Sorry, this is actually on the next slide, so forget to move to the next slide. So also interesting story is when I got this invitation to join the European Time Machine project. Actually, what happened is that Frédéric Kaplan, so he's heading this project, he wrote an email essentially to all projects in Europe working in digital humanities, and he wanted to have help with the translation. And essentially all I did is take his English email, put it into Google Translate, do a couple of manual corrections, and then send it back to him. And I liked the project. I heard about the project. I found it would be nice to take part in this. And I responded, let's say within 30 minutes when he sent this email. And because I was very quick in replying with the translation, he thought I would be a very good addition to the team. And then I was joining this effort at a very early stage. And now I'm still a board member at the consortium. We went on to apply for a so-called FED flagship project. So that's 1 billion euro of funding. And this is also one of the downsides that people typically don't talk about. So there were, I think, approximately 30 projects that we started off with competition. In the first round, it was reduced to 18. Then those 18 projects went through another call and another round of reviews. And in the end, they narrowed it down to 6 projects. And of these 6 projects, 1 or 2 were supposed to receive 1 billion euro of funding for 10 years. So there's the Human Brain project, for example, that is financed within this kind of framework. And then I can tell you, even they put out the scores and Time Machine was ranked #1 in this last round where they selected the final 6. And we were like, wow, this is cool. We really might get it. And then the European Union, the current framework program, Horizon 2020, ends in 2020. And then there will be a new program that's called Horizon Europe. And Horizon Europe doesn't have the flagship mechanism anymore. So we were this close to receiving 1 billion euro of funding for 10 years with like 40 European partners. It's a really big scale project, incredible amount of money. And although we did our best and we really got selected, the funding mechanism was killed. So right now we are in negotiations with the European Union, but it's really a hard thing and we're trying to keep it going. And there's also other ways of getting this, but you know, it's also a really big disappointment if you do so well and then suddenly somebody says, oh, look, we decided otherwise, we won't fund your project. Although you've been doing really well and you wrote this wonderful grant, I'm sorry, bad luck. So I think what I want to tell you, and these are kind of the takeaways that I think that are important, is that you really should identify chances and take them. So the chance of going to Stanford, the chance of going to Japan, although I didn't know very well about speech recognition, I decided, okay, I'll do it. And although I didn't know very much about the image reconstruction, I decided to do it, and it turned out to be a really good idea. And I made, also going abroad, I made really, really good contacts, and this network is still going on. I'm still in contact with many of those persons, and this was a wonderful experience. But be sure that if you take tasks that you really want them, there's nothing worse. There's this Chinese proverb that says there's nothing worse than having to go to work every day. So if you have to force yourself to work with those colleagues, or if you have to force yourself to work in that particular field, maybe it's not the right thing for you. Don't do stuff where you can't get passionate about. If you can go passionate about them, then you will also be able to do immense amounts of workload. But you have to be passionate about them. If you're not passionate about what you're doing, if you don't like programming, and if you don't like puzzles and so on, then maybe computer science or machine learning is not the way to go. Don't just do it for the money. If you're just doing it for the money, it might not be the right idea. Then, of course, don't avoid risks. Yeah. So there's this nice proverb: fortune favors the bold. Fortune favors the bold, and this is something that's also important. You can do a bold move. Don't do them too often, but if you really want to do them, a bold move is also okay and may pay off. Don't be over bold, but if you think you can do it, if you're capable, if it lies within your capability, even if it's a bit much that you're biting off, you have to chew all of this down. It's going to be a lot of work if you do a bold move, but you can get through with them. And I did at multiple stages of my career. I did a very bold move, like submitting this ERC grant, which has a less than 10% likelihood. I never thought it would ever be funded, but still we were trying it. And then, you know, we really liked our grant. We liked what we were doing. We put up a very convincing story, and turned out that we were the first ones that really did this hybrid AI CT reconstruction stuff. So this was really new for all of the reviewers. And then we got lucky and the project got funded. And also remember the law of large numbers. Even if there's a slim probability, you might not get it. Don't be disappointed if you don't get it, but you might get it. And if you try often enough, then you will get it eventually. It may not be exactly what you wanted, but you have so many different opportunities. You don't have to be fixed. I just want to do this single position. This will probably not work out. But if you're flexible and if you identify enough chances, then you know, you can also be rejected like 40 times for a professorship. Even in the end, if you find one good position for you, that will be enough. You don't need 40. One is sufficient, but one you get passionate about and one you really like. And then, of course, another thing, you should get up at least once more than you get knocked down. You will get knocked down all the time, but you have to get up this only once more than you have been knocked down, and you will keep standing. Also, keep your contacts. And a former supervisor told me, so she told me, don't annoy other people. And I think that's also a very good advice. Yeah? Don't piss off other people. You know, don't react in a way that they could be offended. Because communities, in particular research communities, are small. And the likelihood that you will encounter the same person again, but in a position where this person judges your work is very high. So if you annoy other people and if you start fighting with other people, it's not a very good strategy, because there's plenty of opportunity that they will kick your back. They will kick you in the back and you won't even notice. So don't annoy other people, don't fight. Always be friendly. If you go to interviews and there's a lot of competition, there's 10 other people interviewing for the same position as you. Be friendly with them. Actually, I met people in interviews that I still collaborate with because we got along very well. So they are also experts in a related field. So you can use this as an opportunity to establish new contacts. So don't annoy other people. Also, when you're in competition, your relation may change very quickly because they're also following a similar career pathway as you. So your paths will cross again. And then it's always better if you're meeting a friend than an enemy. Okay, so I think this is all that I prepared and that I wanted to say in this kind of fireplace talk. Keep your network, build an international network, build a network all across the world. Oh, I forgot the story how we met Asif. So I wrote an email to Asif because I saw that you made this list of free online learning resources, and then you added me to this list and we started off having a first interview, and then I was starting writing blog posts for you, and now I'm in this kind of online meeting, which is also very enjoyable and very cool. So take those opportunities. Sometimes it might have seemed to Asif that I'm sending a random email, but we got this very nice contact. So take these opportunities, keep your network. And I think I have one more slide. Oh yeah, this are contact details. If you want to follow up later after this, you can also contact me on social media, website, Twitter, and so on. Yeah, so now I would be ready to take questions. And Asif, thank you very much for this wonderful invitation.
Thank you, Professor Andreas. It was really a very inspiring and interesting talk. How you like change your career pathways, how you entered into professorship from Stanford to Germany, back in Germany, and the obstacles and the good news and the bad news. But ultimately, the good news matters as long as you're consistent. So thank you very much for sharing your story. And so we can open up the question answers now. And if you guys have any questions. Mm-hmm. And then Professor Andreas has his YouTube channel, and you can follow him on Twitter, and you can also subscribe to his YouTube channel. He's providing most of the university lectures, whatever he can, on the YouTube channel as well, and he can share with the link in the chat. And if no, then I would like to share my screen and share some stuff really quickly, which might be useful. Yeah. So this is the YouTube channel for, yep. So this is like really cool, and I really enjoy going through the videos. So feel free to subscribe, Professor Andreas, and his Twitter account is here. So you guys can find him on Twitter with this name. And then apart from this thing, I would also like you guys to visit, if you are looking for research materials, you can go to definitely Professor Andreas' YouTube channel and his lab. There's a lot of study materials available through him. But apart from that thing, there's a lot of study materials we have also collected from different universities, and these are all free. So if you go to marktechpost.com and go to free resources, you can find lecture notes from all over the world, including FAU and Stanford and all those things with different topics here. So books, research materials, courses, everything you can find it here. We try to update it on a daily basis, and you can find everything here. Also, if you are looking for YouTube videos from different universities, including FAU, we can find over here most of the most trending videos here. And yeah, feel free to visit our website. There is no charge for visiting the site or using any of our services so far. And you can also go through all the tools. We try to publish the trending articles, not the business related articles, more about the research, but in a very summarized way where you can understand the topic in less than 2 paragraphs. And we also provide the GitHub link directly here, so you can go through the topic and learn about this thing. So with this, all right. All right, so if anybody has any question, can ask. Otherwise, we can conclude the session.
Yeah, thank you very much for attending.
Yes, thank you,
Professor. Thank you very much for the invitation.
Yep, Professor Andreas, thank you so much. And it was really informative. And we're looking forward to working with you and talking to you in the future as well. And thank you everyone for joining the session. Really appreciate it. And we'll keep you posted with our next sessions. And you guys can follow Professor Andreas and MarkTech post as well. So thank you very much. Have a great day. Have a great evening. Take care. Bye-bye.
Bye-bye.